Hey guys, welcome back. Day 4, we're going to talk about the classification of matter. All right, so matter, as you guys can probably tell, goes in the first box here. Matter. So matter has mass, space, has physical properties, right? It's solid, liquid, gas, right? Plasma behaves its own way as a fourth state, but we're just turning to a solid, liquid, gas, right? It has mass, right? It has a solid, liquid, right? It can be gas. It has a melting point or boiling point, maybe. It has density, right? It has a color or no color, colorless, right? It has these properties, right? And what is matter? Well, it can be a pure substance. All right? It can be a pure substance. And what are the pure substances? Well, those are elements, which are made out of atoms. So we talked about the periodic table already. It's got the atoms, 118 different, right, atoms. Right? So those atoms are the building blocks of this matter, right? And so each element is unique, right? And they are pure substances. We can also have a combination of elements, which would be called a compound, right? When two atoms or two elements combine, they form a compound. Like water. Most people know water is H2O. Right? That's two hydrogens and an oxygen get together and they form a compound. Now, they would still be a pure substance. However, you can also have a mixture of substances. So if we have a mixture of substances, we can physically separate the mixtures of the pure substances. For example, right? Again, you guys know I live by a lot of military, and a lot of military like to wash their cars, which is fantastic. It's nice to have clean cars, right? Where I live, we have what we call hard water. Now, hard water, a lot of times it's calcium and magnesium salts dissolved in the water. Like there's no pure water on the planet. Even fresh water is not 100% just pure, right? And water spots are what happens when water evaporates. It goes from a liquid to a gas, but the dissolved solids stay behind, right? Those are the water spots. There's actually nothing to do with water. It has to do with like dissolved salts, right? And so you can separate water and salts very easily. You just boil the water away. That's a physical separation. You didn't change the chemical identity of the water. You didn't change the chemical identity of the salt. All right. Now, when we talk about mixtures, there are two types of mixtures. There are heterogeneous mixtures and homogeneous, or homogeneous, some people call it, right? And a lot of times we're going to call this homogeneous mixture a solution. Technically, it's based on particle size, but we're just going to live, in Chem 1 here with homogeneous mixtures being solutions, right? Air is a solution, right? Ocean water that doesn't have anything solid in it is a solution. Where heterogeneous would be like salt and pepper together, would be heterogeneous, okay? So if we look at this, elements here, so if I had some elements, H2, which is a gas, that's a state, plus O2 gas, that would be an element. A compound would be H2O, which at room temperature, that's a liquid. All right? So those two, right? These are elements. That's a compound. Right? And so what's the difference? Well, hydrogen and oxygen are elemental. They're very reactive. In fact, if you had a mixture of hydrogen and oxygen together and you gave it a match, it would explode very violently and loud. Water, it's a liquid. and you gave a sample of water a match, the match would go out, right? And so the water has its own properties that are totally different than hydrogen and oxygen, right? Which is just the way it is, right? Because you put the building blocks together differently, they're going to behave differently, all right? Okay, and we can break down, you can technically go the other way. We could go that way, right? Give me a tail here. We can go that way. We can actually go take water and break it down into hydrogen and oxygen, right? So it can be broken down. The elements cannot be broken down, all right, by chemical means. Can you do nuclear chemistry? Yes. But I can't go to the chemistry lab and break down the element, right? So elements, right, it's a substance that cannot be decomposed further by chemical means. Again, we can't go in the lab and do it. As a symbol. Now, it's very important. These symbols, it's always capital letter, lowercase letter, right? Capital letter, lowercase letter, right? So, for example, CO versus CO. That might not look that big of a deal, but writing neat, you need to know this, because if you walk in a room and it says, 25 kilograms of CO on the door, danger, well, 25 kilograms of cobalt's probably not going to do anything to you, right? It's just sitting there in the corner. But if you had 25 kilograms of carbon monoxide in the air, right, that'd be very toxic to us in the room, depending on how big the room is. But that's still a lot, all right? That'd be very bad. And so you got to know, every time we see a capital letter, it's another element. The lowercase ones, right, we got to know that that's the continuation. And it becomes important, right? CN versus CN minus. Or that's the best. Where you do C and N. Like, I don't know what that means, right? So when we write these things, we want to be very clear in our communication. All right? And as we know, we already talked about some of the elements having different names. We'll mention that in a second. All right, the smallest particle of an element is the atom. All right, that's the atom. And some elements exist as molecules, like S8 and P4. The 7 diatomics, which we don't tell you that, right? I will tell you that sulfur is S8 because there's other ways it can form. I'm going to expect you to know the 7 diatomics that we talked about. H2, N2, O2, F2, Cl2, Br2, I2, right? Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, right? And so we say molecule here. What is this molecule? Molecule. Well, a molecule is a small discrete unit of atoms bonded together, all right? And so that means it's a small group. Now, some of these molecules actually do get large when we learn how to draw them and stuff, but it's still a small discrete unit bonded together. And here are some of the names that were in existence well before English was a language. All right? So that's why sodium is Na, potassium is K, iron is Fe, copper is pretty close, but that's why it's Cu, silver Ag, all right? And gold Au, tungsten is W, Sn for tin, Sb for antimony, lead Pb, and mercury is Hg. All right, and so now you can see kind of why those letters are, right? You can kind of see the letters that they have, right? Na, K, Fe, Cu, Ag, Au, W, right? Sn, SB, PB, HG. Right, so that they're not just random, like, wow, where did that come from? It actually came from something. All right, that leads us into compounds. All right, combination of elements. All right, now there are 2 main groups that we are going to worry about, which are molecular and ionic. Right? How do I tell the difference? Well, molecular, right? These are above the stairs, and hydrogen. And these are below the stairs. What does that mean? These are metals. plus a nonmetal. And these are all nonmetals. Okay? So whether it's a metal and a nonmetal or a metal. So opposite sides of the stairs, ionic, above the stairs or close together on the right-hand side with hydrogen is molecular. Or sometimes we'll refer to them as covalent. Okay, so now, examples. H2O has a common name of water. All right? CO2, carbon dioxide. And CH4 is methane. All right? Then we have NaCl is sodium chloride. And this last one is copper 2 nitrate. You might recognize NO3 as a polyatomic ion. Hopefully you recognize that. So now, the ones written in blue, all right, these are molecules. And the ones written in green here are ionic compounds. All right, and so if you look, H2O, nonmetals, CO2, nonmetals, CH4, nonmetals, NaCl, metal, nonmetal, copper and nitrate, copper, metal, nitrates are nonmetals. All right, so what's the difference? Right, what's the difference? Well, they have different properties, okay, and they're put together differently. And we'll get to that when we actually go into naming them and whatnot. But we're just giving you those classifications now. And we talk about properties, we got chemical and physical properties. So there's properties. There's quantitative and qualitative properties. Quantity, think about a number, right? Quality, think about qualitative, think quality, all right? Okay? Right? So you have a height. Shirt size, a foot size, an eye color, right? These are quantitative properties of you, right? What size glove do you wear? What size pants do you wear? Right? These are all qualitative properties or quantitative properties, right? Now, your appearance, right? That's a qualitative property, right? Hopefully my wife thinks I have a good appearance, right? But that's a quality. That's not necessarily a quantity, if that makes sense. All right? And so when we talk about those properties, there's other also physical properties, and there's two types of observable. I like to use observable for physical properties. Right? So an extensive physical property depends on the amount of substance present. So that would be mass or volume, right? Okay, how much water did you drink? That's an extensive property, right? Because it has to do with how much. Now, intensive does not matter, all right? The density of the water you drank doesn't matter how much you drank of it. The melting point or boiling point of the water, right? Okay, the density of the water did not matter how much was there, okay? And so now, when there's changes of matter, like as matter undergoes changes, right, we have physical changes where the identity does not change, and chemical do. So what are some chemical properties? Let's list some of those. Some chemical properties. All right, and some of them would be, just think behavior. Right? And so some of them, right? Toxicity, flammability. I could spell today. We have corrosiveness. acidity. We have oxidizers. And there's some more, right? Think of these as observable through chemical changes. All right. So some examples here. Right? We have ice to water. Is that a physical change or is that a chemical change? Well, ice is H2O, right? And it has a state of matter that would be solid, right? Solid ice, solid water. Going to H2O, and that would be a liquid. Well, if you notice, it has the same chemical composition, right? So that means this would be a physical change, right? If that makes sense, right? It's still H2O, right? And it can go backwards too, right? Hydrogen and oxygen is the next example going to water. Well, that was the first one we did way back up, right? Where you had H2 gas plus O2. Now, some of you might have realized, right? Now it's balanced, if that bothers you, right? In fact, I can scroll up and change that, but I'm not going to, right? You just know that we're not balancing equations yet, right? That's much later. But that, right, these are different, right? So this would be a chemical change. The chemical identity changes. Sulfur burning, right? Burning, that would be chemical. Most of the time, that is a reaction. Burning is plus O2, right? So hydrogen and oxygen, that's hydrogen burning, right? A lot of times it's plus O2. It's an oxidation reaction with O2. Dissolving, right? That, just so you know, I would have NaCl solid means going to NaCl that is in solution. That is not a chemical change. It's still salt, right? So that would be a physical. Flashlight battery running down, right? Always got to have flashlights, got to have batteries, or if they're rechargeable batteries, they got to be charged, right? Again, if you live, like where I live, in a hurricane area, a potential hurricane area, right? We always want to make sure, June 1, we don't really get many hurricanes in June. But we already had a storm come kind of close. We always have them, so always have your batteries, right? Got to have batteries, got to have a generator, all that fun stuff, because we're made with electricity. So if you have a flashlight and it's a new battery, it's bright and it's working great. But after a while, those batteries get dim. And when they get dim, right, that's because a chemical reaction is going on and the amount of reactants and products have changed. So this is chemical. So that would be a chemical reaction, right? So that is the classification of matter, right? And some of the properties it has. So hopefully that works for you guys. And that is the end of the first chapter in this book. We will catch you next time. Let me know if you have any questions. Take care.